Hello, how are you? How are you
Good.
doing?
How are you?
I'm good. Thanks
Sorry,
for
let me
having
just.
me.
Yeah, of course. Thanks for taking your time to be here with me today. Uh, and you don't mind if this is recorded, right? Just want to share
Yeah, sure,
this.
go ahead.
Okay, great. So the lighting's kind of being bad, but um yeah, so we just had a couple of questions. And I can address you by Dr. Bhaskar.
Call me Adithya.
Aditya? All right, that works out. Uh So yeah, we just had a couple of questions about your work at Princeton and UT Austin. And we were really interested in all the work that you were doing. So yeah, great to see you and speak to you. So do you mind if we just get started? It won't be too long, of course. So could you start by telling me just a little bit about yourself and like your journey in computer science? And I know you work in LLMs now, but just like computer science, AI, natural language processing, that realm in general.
Yeah, okay. So I would say like my path today was kind of just out of fortitude. Because if I think back to high school, I was kind of not interested in computer science. Like even in computer science, I was just interested in like math and physics. But this was back in India, and we have this like entire like entrance exam system where you have to like with this exam on like math, physics, and chemistry, and somehow that is used to sort you into these like programs for like computer science and like electrical engineering and everything else. Which is, I think maybe that's not like the best system. You should probably be testing computer science aptitude if you want like computer science students. But long story short, I just so that basically I did well on that, and I got into like computer science program. And back when I just didn't know much about computer science at all. But typically, like in the first few courses in university, what you will see is you will see that you will have your programming courses, you will have like these algorithm courses which are like somewhat of theory, like somewhat theory, but they also have like a programming component to them. And in the beginning, I was like super into these like algorithm courses because they were closer to like what I liked, which is math. But then as I kind of progressed, I saw that they were kind of extremely theoretical. Like they're not as theoretical as math, so you can't really claim that you're like doing like purely intellectual work. Also, it's at the same time, it's not like you're it's not exactly like you're building like systems or doing something with it. So I wanted to like explore something that was like a little more kind of empirical, had like some kind of contact with algorithms. And then I took this course on like speech processing. It was not natural language processing. I remember this kind of distinctly. And like when I took this like course, which was taught by like a professor called Preeti, and she was like excellent at like you know like one of the like strong points about her method of instruction was really like she had all of these kind of hard questions, which were in hindsight maybe not very realistic, but they kind of had this like algorithmic angle to them. And so I had this like early impression of, oh, this like speech processing and like natural language processing, maybe they are like this perfect empirical experimentation, and this like also like some amount of like algorithmic design. In hindsight, I think like my guess was kind of wrong. It is like a little more towards the empirical side. It doesn't have too much of like theory in it. But what it did is like it got me interested in the field, and I reached out to like Greg at UT, and I told him, I'm kind of interested in this. I saw that you've done some like good work here. Would you mind having me for an internship? And then I ended up interning with him, and then yeah, I liked it. And now I think like I don't really like do it for like the algorithmic side or the math side or anything. I just like it's kind of nice because you can actually see like the results of what you do in practice. It's not really like like in a lot of like systems you will like evaluate your proposals in simulation because it's too expensive to do anything with like real
Mhm.
systems like real cluster or something. I think NLP is like in this like sweet spot of you can like do something empirical, but you can also test it out. You can if there are some problems you can still like think about theoretically. You can spend time like actually like brainstorming other than just keep doing things. So yeah, that is like the story of how I got into it.
Yeah, so I read your bio and I thought it was very interesting. You've worked in a lot of separate fields, and I saw your recent publications. They're all over just the general field of natural language processing and everything connected with them. So, you had a bunch, and I saw a lot of projects on your page. So, if you had to summarize, what would you say are your, I don't know, three or like top most favorite, most interesting I know, I bet they're all very interesting, but like what do you think are like your most interesting problems that you've worked on in the field?
So I would certainly say the most recent one, the heuristic core paper,
Hmm.
probably it was the most interesting to me. I think it's maybe not super impactful in the sense that it's not directly useful, but I think it's really like, it's on the like side of like, you have a hypothesis, you think deeply about it. You think of like what is like, like the best way to like evaluate this hypothesis, and then you find something that is like contradictory to it, but it's not just like noise, it's exactly like contradictory, which means there's some information there, and you like, and it's like an investigative kind of piece, which is I
Hmm.
think really nice. Uh, the other thing, maybe I would say even this like this was not even like a paper project. This was just like so I have this like course project thing that I did like for a speech processing course, which is I took this proposal, which was they had this like method called metric plans, which is like I won't go into like the details. I think they're too boring, but like, basically they are like a spin-off on like an existing kind of network, and they claim, oh, this is like so great, it does like so well, and so on and so forth. And I tried to replicate it, and I couldn't like I couldn't get it to work. And like the typical like go to explanation in those cases is, oh, this is just sensitive to hyperparameters, or like some kind of boring explanation. Uh, Basically that project I tried to like explain that using like not just like this kind of blanket statement of like, oh, hyperparameter tuning and so on and so forth. It's more like, oh, why do we have this like instability? Like, what is different about the spin-off that like actually makes it more unstable? Like, how do we like fix it? And yeah, I think like the issue was that this modification like introduce some kind of a feedback loop where it makes it easier for you to kind of keep ping ponging between like two suboptimal states and never get out of them. Uh, I think that was very interesting, even though like again, it's not like very useful
Hmm.
sense.
Yeah. Yeah, that's very interesting. So regarding was your most recent heuristic core paper the one titled Subnetwork Generalization in Pre-trained Language Models? That was it. Yeah. Do you think you could give like a simple overview regarding that paper?
Yeah, so okay, the starting point is back in 2020, right? There were these like people who like took like, the same like pre-trained language model, they created multiple clones of it, and then they like fine-tuned, which is like further trained these like clones in the same data set, like different random seeds. So they are the same data set, but you see them in different orders and so on. And then we found that these like the models that we get out of them kind of, they perform very similarly whenever you evaluate them on this like test set that comes with the data set, but if you evaluate them on like these other settings where they're not necessarily meant to be evaluated on, perform very differently. And then they like, they investigate it and they find that they implement like different algorithms, which is very interesting because you have, it's the same model, but you just like initialize it with different seeds and you get different results. So in our paper, like our starting point is instead of like taking different models, what if we just like took the same model and like, the intuition here is really, okay, let's say you have like algorithms like A1, A2, and whatever, right? Like A5, you basically just train it by like maximizing probability of tokens. Like there should be like, no intuitive reason why it should prefer like A1 over A2 or like A2 over A1.
Mhm.
So maybe it's not preferring something. Maybe it's just learning all of these algorithms and it's just like learning some of them more because it found like maybe like those examples floated together or something. Right. So like in our case, we like tune a language model, which is like we like knock out certain components, we find different subsets of the same model perform as well as the full model like in domain. So they have the same performance whenever we evaluate it on the same data set. But whenever you evaluate it on these other settings, all of them perform very differently from the model. So this is like the first part, which is basically kind of a proof that the model like can actually learn different different approaches to the problem at the same time. But then we kind of investigate, like what is the
So
exact like
can I
mechanisms
jump in there? Sorry. So you're talking about one model and separate parts within the model, separate algorithms within the model are learning different like features more than the other in a
exactly.
sense? Okay. All right. Yeah. Sorry. Continue. Go ahead.
And then like, the second part of the paper is like more technical, and like we kind of analyze it and we try to like explain it like in a more concrete fashion, right? Because like you want to be able to say more than, oh, it just learns different things.
Mhm.
So like, we try to draw this like parallel to like a phenomenon called blocking. Just like, if people have studied this like very, very tall neural networks, so literally like one layer network with like couple hundred parameters. These are like millions of times smaller than your typical model. And they found that if you train them on these like tiny algorithmic data sets, like 1-digit addition, for a long time it will just like not generalize at all. Then at some point it will just suddenly generalize. It will just like such like a phase transition. And after like a lot of experimentation, people have found that in that case too, it actually learns two solutions. It learns to memorize the data, and another one is actually it learns to do the addition. Kind of switch it over from like one algorithm to the other. So we try to like adapt their experiments. So in this case, like their concrete experiment was you try to again find like these tiny subsets of the model that are good at this task. But then, as you go along, initially it's all memorization. So you find like not like subsets that are not so tiny because you really need like a lot of parameters to memorize every single thing. Then as soon as you learn to generalize, you basically don't need all of these data points. You just need to know how to add two numbers. So basically this like the size of the subset kind of drops sharply. So we do the same experiment and the expectation is, it's gonna drop sharply and we're good to go. Here's the surprising thing, like instead it rises sharply. Like in our case, initially you need like a lot fewer parameters, and then suddenly the amount of parameters increases. Just like it seems contradictory. Then we like investigate further, and the point of the paper is, initially the model learns like a common set of parameters that do these like very simple heuristics that like don't generalize at all. It's like superficial surface level things like, oh, like the same words appear in like, part A and part B and so on. Right? These are not really helpful to like solve this test. Some guesses using them, but the guesses are just like heuristics. But then later it learns these like other components that we talked about in these different approaches. And one of these approaches, rather than like working with this like underlying input itself, it works with these like superficial features extracted by this first layer, which is like, it's like it looks at, oh, like do the same words appear? And it also looks at, let's say, this also happens for the next word and so on. So then you can like, some higher order primitives with it. So our work is really like tries to like combine these like explanations of these like phenomena for these like super toy models, like these extremely toy models with this repeating some subnetworks do different things hypothesis. And we try to combine them to give like a cohesive explanation of a much larger model, like a more realistic model. Right?
So in regards to that addition analogy, you would say like the model never fully understood the idea of addition. It just started gathering more superficial information. It never fully put together the addition feature, or
That is possible. I'm not super sure we could say that. Like there might be some way to implement, like whatever is
Mhm.
the equivalent of like addition in our case, which is like finding if two statements are equivalent. Maybe there's a way to implement it using like these different superficial features because you don't have just one, right? If you have just one, maybe it's hard, but you have like hundreds of them, like
Mhm.
maybe tens of them. Right? So it's like maybe you can combine them in like in certain ways. So like okay, so let's say your feature is I have two statements. I have to say if they're the same, and my feature is just like this word in this premise also occur in this other sentence, right? But then like one way to use this would be like you check so this word you also check for the next word, you also check for the previous word, and then you also check whether like and then you also do let's say some kind of parsing. You figure out like some kind of oh what does this word refer to, and then so this word A should also appear in the second sentence. The other word that it like kind of refers to should also appear in the third sentence. You can like kind of use these to form. I don't know if you would call them generalizing, but you can use it to form like better approaches that like certainly are not like just heuristics.
Mhm.
I guess it's a challenge to even like categorize them precisely as to like what do they exactly
What
generalize
it's
or not.
doing. Yeah.
Yeah, but the general idea is like you can get there by composing these heuristics, which is what we showed because like you would typically assume that okay, like one is memorization, one is like you learn the thing, right? Like there's no overlap. It turns out actually the pathway to generalization actually passes through these kind of approaches like fail or like don't
Mhm.
generalize.
So there's no distinct border between taking the shortcuts and the final product. It's sort of a culmination of everything.
Exactly.
Mhm. So what do you think would like, regarding that body of work that you did there, what are the real world applications or the further applications of that kind of that work?
Okay, so I think the biggest real world application is probably okay, so a little bit of background here. So I talked about pruning, right? Like removing parts of the model. So this is actually very like popular in this field of NLP, but never not really for interpreting the model itself. It's more for like making the model smaller so you can run it more efficiently and try to preserve as much of the performance as possible, right? But like our like experiments showed, for instance, that you can still maintain a lot of performance on these like test sets that you will like use to benchmark this approach to. But in reality, you're actually like not generalizing very well anymore. And so far, all of the papers that was pruning, they don't really like evaluate on like all of these like out of domain data sets. It's often just on, oh, we prune on data set ABC, we evaluate on ABC, and look, we're good at ABC, right? So one like takeaway is like that might be insufficient. You might like, it might not be that easy, or like even if you compress the model so much, you might actually be losing something,
Mhm.
even if you don't think you are.
That's an interesting conclusion. So I assume that there's a lot of issues that you came into when trying to put together this work. So what do you think are the key challenges that you tackled trying to put this together?
I would I would maybe categorize the challenges into like three parts. So so one challenge is really like, you know, what is a good way to implement what you have in front of you, right? Because with the paper, obviously, you always write like at the high level, you write at these
Hmm.
abstract away things like code and so on. But in reality, you have to like go there and code it. And if you like, if it is slower for whatever reason, you have to figure out why it is slow. And all of these things are kind of annoying. They are kind of, they won't directly like give you any new ideas, but they are necessary. So one challenge is like, if you try a lot of things and they don't really work out or like they're very slow, something happens, you have to figure out, is this because like the approach itself is bad, or have I like coded it wrongly? Do I have like a better
Hmm.
way to code it out? And for that, I think like really like what I would say helped me is to look at like this other code base that did something similar, but they did it like very inefficiently. Like I think like this other code base that I saw, did very inefficiently, and they're like neither of our papers like worries about like efficiency. Like, it's just we want to find these components. But I saw that they did it like very inefficiently, and so I was like, okay, I'm also going to do it inefficiently. And then like sometime later, I actually found like some better ways to do it. But like uh, it was helpful to have some kind of an indication of, okay, this is something that's okay in this paper because it's not your focus. And so I would say that is like a operational challenge maybe. And then one other challenge was like, so we had this hypothesis out like in the very beginning that like maybe like subnet was also generalized essentially that we want to explain it. So one question is like, how much do you actually believe, like, when do you think you should give up on like a direction? Because we tried like a whole bunch of stuff in the beginning, like we didn't try this pruning stuff. We tried like simple things, which is just look at the components, look at some attention patterns, see sequence patterns, and we found none. So I think like one question really was like, like, should we abandon this or should we, like keep sticking to it? And I'm not really sure like I did anything specific to like overcome that challenge. I just think like at some point either you feel okay, it's not worth pursuing anymore, or you think maybe I should give it one more try.
Hmm.
I don't know if there's like a science behind it, or maybe I'm just too junior to know here. Maybe like a more senior PhD student would know this better. And then the third challenge, like, okay, so when you start like doing, okay, so like I guess like when you're in like high school, that you are, right?
Hmm.
Or even like when you're undergrad, or uh, maybe even for me, it's like a lot of research is just like fun. Like, it's like fun stuff because you want to do things and you can like do those things. But then when at some point you have to like write a paper, right? And then when you write a paper, like, the focus kind of completely shifts because now you're a salesman. Like really, at some level, I kind of wish that this would not be the case, but maybe it's a good thing. I don't know. Like, you have to like really sell your work. You have to like be objective because you're after a researcher, but at the same time, you also have to kind of sell your work. You have to say, oh, this is like useful because of ABC. Look at this
Hmm.
is exciting, and uh, both can be at odds sometimes. In fact, like I think they're at odds in almost like every paper. So it's like I think it's really an art to like learn to write, which is like, in a both objective manner, but also like convey the excitement that you have for this project for other people. And I really I benefited from like one senior PhD here called Dan. So yeah, he also has like a degree in English on top of the computer science
Oh,
degree.
okay.
And like yeah, like that's like a day and night difference between like how I write and how he writes.
Hmm.
I think that was like a huge help in this case.
Hmm. So regarding that topic, is there any specific points within your paper where you can point out maybe like off the top of your head if there's any that they use specifically like objectified, put them in an objective manner while at the same time putting it, selling the product, selling the work. Is there any specific, portions in which that you can talk about where you perform that kind of thing?
Yeah. So like in our paper, right, like you have this thing I told you about the common set of components that I learned first. So like in our paper, we have like a name for them. We call them the heuristic core because we define that they're in a sense a core because they appear in everything, and they're heuristic because they don't generalize by themselves. But like our initial way of writing the paper was we have like two hypotheses. We have like the competing subnetwork hypothesis, which is the grokking thing, like effective size stuff, which we try and we find the opposite, right? And then we have the heuristic core hypothesis. And we compare both and we find that this hypothesis is correct. But I think that is like a hard sell. Because if you actually like make this heuristic core thing like an entire hypothesis, you also have to provide like other forms of evidence, right? You also have to like completely rule out this other like subnetwork hypothesis. You have to say like both cannot be true at the same time and so on and so forth, which we had like a little bit of a hard time justifying because we had like strong piece of evidence, but it was only one piece of evidence. Uh, so this like I was trying to like make this angle work, and then like Dan came in one day and he was like, "Can you put, like a copy of this like LaTeX file," and then he just like deleted all of the text and like rewrote like a version in which this other part is not really a hypothesis, but it like emerges out of the like, experiments of this like
Mm.
computing subnetworks hypothesis. And I think that's like a much better way to like write it because it doesn't really like make such bland claims, which might be like harder to justify. It
Mhm.
doesn't really say that this is wrong and this is correct or something. It just says you try to like verify this hypothesis. And at least on like this particular angle, like clearly our experiment demonstrates the scaling is opposite. And so for this particular experiment, we look for an explanation, and this is the explanation we found. So by making like our like contribution like more focused in a sense, I think it made it like both uh more presentable and also like less, I guess, vague.
Mhm. So, so for prospective people such as myself and other members that are interested in going into, AI and computer science, how much do you think we should emphasize learning about, writing and learning about English, considering all the new experiences you've had working with your colleagues? How much do you think we should put an emphasis on learning those topics, in secondary to the actual programming and learning that portion?
Yes, I would think that is maybe very useful. But also, I think like in talking to you for now, for instance, I think like you have like a great way to conduct yourself. I already, I think that it's like I think maybe a lot of you will already have this plan because like especially like because I was like uh English is like a it's kind of a first language for me now, but I was not born in the US, so you can kind of
Mhm.
make out the make like the map of the earth and so on. So you might have like an easier time with this. Uh, but on the other hand, maybe you should also like not, you know, already decide that you will do like AI, for instance,
Yeah, for
or
sure.
something, right? Because like there's quite a few years ahead of you, and like, and this like I think like happens very frequently. You just like think something is very interesting, you do it, and it's very interesting in the beginning. Then you maybe get bored of it for some reason, and then you try something else, and then you think you won't be interested in it, but you actually are interested in it. So like from that viewpoint as well, I think like maybe these other skills like I don't know like good writing and so on, these are like usually transfer across fields. It's not like you have to like acquire them anew after every single
Mhm.
decision. So maybe they're kind of useful. Also, yeah, I don't. I think okay. The one main difference I think between like the math stuff that I used to do in high school, right, this research and right. I feel like research is a lot more of work. Like it's a lot closer to work. So like math for me is just like a tick problem. Let's say whatever Olympiad problem is in front of me, and I'm like, okay, I'm going to solve this Olympiad problem now. And I just like okay, so whatever, 30 minutes an hour towards it, right? Or not be able to solve it or whatever outcome.
Mhm.
But it's literally just like so contained that you can just focus on the problem. If you're doing research, there's like a lot more of added baggage. You have to like you can't really like just focus on it for like an hour. You have to do commit to it and like do a lot of work. Like there's a lot of like, getting it done, which is like, I think like such the slog is, I don't even know if it's like really like helpful in your development or anything's development, but it's just something that needs to be done. So at some level, like, at some point, like you will also like slowly transition to like from like curiosity to like curiosity plus work.
Mhm.
I hope like neither of us like ever make it to your work in your curiosity domain, but like some people are in that like are in that space. It's like it depends. Like like as long as you have an opportunity to like, not get bogged down by work, I would grab it with both hands.
Yeah, of course. Right. Yeah, lots of good topics there. So just a couple more general questions just to wrap up. So considering all your work with the language, writing the paper and human interaction, how do you envision the role of humans and AI changing? How do you envision the role of AI changing in terms of natural language understanding and reasoning in the future? Do you ever foresee AI, matching or surpassing the human capabilities in those fields? I know that's a hot topic right now, but more broader than that, right? Do you think how do you think the role of human and that AI like collaboration changes? I know that's kind of a loaded question, but you know, just the future of AI and reasoning, natural language reasoning.
Okay, to start off, I think that these language models are like AI in general can certainly surpass humans, like specific in any domain, but like just like okay, let me try to explain this. So it's like we had chess, right? Like in 1980s, people thought like a computer program is like an idiot, it's never going to beat humans. In 1992, I think like it was the first time that a computer program actually like, defeated like a master. It was not like a grandmaster or anything. It was just like a serial master or something like that. Then in 1997, it was already like defeating Garry Kasparov. But now, of course, like, they're like so much better than humans that like, I stand a better shot against the world champion than he does against
Yeah,
his entity. I think in any field, like I feel that it's kind of inevitable that if you apply like these tools to the field, it will become better than humans. But on the other hand, I am personally not like super on board with this concept of like AGI, which is like, this artificial
general.
general intelligence that it just does everything. Uh, I don't know how feasible that is, but maybe we will find that even that is feasible. As for the collaboration between the two, I think you can already kind of see glimpses of this in certain fields. So, like when I heard about this language models first time, it was in 2019. I was not into NLP, but I saw that there was this like BERT model that came out, and then I was just like we had this like programming class or something going on, and then we were learning C++, and then like I was one of the kids like who knew Python as well. So I was like I was just showing off the mega F, and I was like here's how you do Python and stuff, and I was just loaded up this model. And I was like I was kind of struck by how bad like the model was at some of like English sentences,
Yeah,
and I was like okay, and I was like okay, like clearly we need to like teach it a lot more of like what we know to like make it better. But today if I talk to like these like GPT whatever 4 or whatever,
or
it's
oh
clearly
yeah,
much better. Yeah, it's much better than me at like all of these like English related tasks. So like actually there's like a paper from Princeton called Stillness, which I won't go into the paper, but one of their experiments is like, they asked the model to like generate text like all like some 8 different diabolical boxes. It should use alliteration, but it should also include a metaphor that compares like human existence to like, like I don't even remember anymore, but it's like it has all of these like constraints, which a human finds like very hard. It takes like a human like multiple hours to come up with like a nice way to combine them. But like these models can like just do it like as soon as you ask them.
mhm,
So basically, like clearly, these models have surpassed to a point, like or have reached a point where they have surpassed human understanding in at least some sense of the word. Like maybe not in every sense of understanding language, but clearly there's something they know about language that we don't. Or that's how I feel. So what if we could like center the pendulum and say instead of teaching language models how to do something better, we learn from them. Is
mhm,
that like a way to like, let's say like, like try to create like an alternate literature and linguistics that only says like language models and like creates like a new way to like look at
mhm.
language or linguistics. Somehow augment our knowledge with what they can do. I think that would be kind of interesting.
Mhm. So like learn from the models instead of us teaching, learn from them because yeah, you're right. They clearly do have some sort of leg up on us if they're able to do all these things that fast, and learning from them might, introduce us to a different approach, right? I think that's fascinating. And then one last question, right? Where you are right now, a PhD student at Princeton, right? And we're just high schoolers. So from your experiences, I know you touched on topics regarding, not making decisions in what you want to do so early as a high schooler. But what are some general pieces of advice that you would give to aspiring students who, are currently who currently think their future lies in CS or AI? Maybe that's not how it ends up, but that's where their current interests lie. What do you have any like brief pieces of advice regarding that?
Okay, first of all, like, if you're interested in that, you should absolutely like do it. Like, let's say, tomorrow I'm interested in like football.
Mhm,
It might end up that I'm like a bad football player, or it might be that I'm a good football player and I make it to like some extent, or it might be that I'm an excellent player and I like, make it all the way. But in any case, like, so I'm interested in that. Like, it really makes more sense for me to do that than anything else, even though this might be like reality. So you should like absolutely go ahead and like, say what you plan. You will find a couple of things like, if you're getting to like NLP or AI, you will find that like hardware is kind of important. Like, having a good GPU setup is very important, and not all of you might have access to like, the same level of compute as
mhm,
like what a institute like Princeton can give you. Uh, but there are ways around it. You can like, reach out to professors. Like a lot of professors are like unwilling to work with even undergrads, but like you will find like a few who are enthusiastic. You can like work with them. Uh, the other thing, there are certain like questions that you can like answer using like less, let's say GPUs or like less hardware than like other questions. So there are certainly like things you can try to do. Uh, but maybe above all is, okay, I know like, the cliche answer is like, just do what you like and like have fun. I think that will kind of not always be the case. Like for me, like, I always like try to do stuff that I like. I'm kind of very and sometimes I'm like kind of extremely like fixated on it to the extent where I even like know what I really should be doing. But even then, there were like moments when I kind of did not enjoy what I was doing, and I think that kind of naturally happens in like any field or anything because you go in there because you see these five things you like, and there are always like a few things you don't like. So it's like it's a certain like skill to like learn to do those things and like learn to. I am told that you should enjoy doing them. I don't quite enjoy doing these other parts, but I have reached a point where I'm kind of indifferent to them. That is kind of useful. And maybe finally, yeah, maybe just like find like-minded people. It is kind of
mhm,
helpful. I didn't realize how helpful it would be as like a pure person. There are like uh there are like a lot of people here who want to do similar things or like different things. I tell them my idea and then they're like, that's such a stupid idea, it's never going to work. And sometimes you need like somebody to tell you like it's like
mhm,
not going to work. And then you think about it and maybe you realize they're wrong, or maybe you realize they're right.
mhm.
It's very helpful to have people you can like push your ideas off against.
So
So
building
my advice,
like a community
uh,
type of thing.
maybe not even like community, maybe just like two people that you know and then you can discuss with. It can go a long way.
Mhm. Yeah. Well, those are all the questions I have for you today. So thank you, Aditya, for all the advice and input. I really liked learning about your paper. It's very fascinating. Um, any last closing words, I guess?
Uh, sure. I will just say, I know if you're interested in the field and something, so on, but it's like it's very easy to like get worried about. Okay, did I make it to like next institution? Did I do this? I would say like kind of don't worry about it. Like just like I found that if you put in work into anything, like even things that I was bad at, over time you do get good at them.
Mhm,
Like like if you put in the effort, like it will show somewhere. Like you might not get it, and you get something else, or you might. There's also no need to be pessimistic all the time. You might even like end up getting what you want or something like that. So just like I don't know, like don't think like too much about
mhm.
what could happen or like what really like you whether you should like whether your work will like pay off. Uh, it will pay off. I think that most likely it will. Uh, but even otherwise, I think like it's enough. I feel like it's just liberating to like not. It's kind of hard, but once you like learn to like not care about it, it's like that's a nice feeling.
Mhm.
Not have to.
So don't worry about the result too much. Just do it.
Yeah, just think about it objectively. Like think about it to the extent that you will that you need to in order to secure your life. And
Mhm.
beyond that, it's like whatever like what is the worst that could happen? Like, the worst is nothing works out. You just like for me, like for instance, my most dreaded job was like this like working 9 to 5 job and having nothing just doing anything. And I know for a lot of people it's like a nice job. So for me, like just like not making any progress in life. Now that I think about it, it's not a bad option, I just go to an office, do some work. But, so like yeah, like a lot of bad outcomes are not really that bad, so don't worry
Mhm.
about things.
Right.
The upside is high. You should.
Mhm. All right. Well, thank you so much for your time, Aditya.
Like, thank you for having me.
Of course. Thank you. Have a nice day. Bye.
All right, you too. See
Bye.
you.
See you.